Okay. Hi, everyone.
Hello.
Okay, on this call, we have the addition of Axiom Zen, which is most known for making Cryptokitties. Do you guys want to give an introduction?
Hey guys, so I'm Lane and this is Fabiano. Fabiano wrote the smart contracts for Cryptokitties and I'm on the product team. We wanted to chat today. Excited to hear from all of you and hear about your thoughts on Plasma and Cryptokitties. So yeah, good to be here. Thanks.
Cool. Yeah, it's great to have you here. I think we'll go over first like updates, and then we can go over I think Carl has like an agenda as well.
Rough agenda. It's more of a straw man agenda.
Yeah, I think it's great. Yeah, who wants to kick it off? And maybe David or today should be pretty chill when it comes to updates. I think it's mainly talking things through his introduction.
Hey.
Hey, David.
What's up? Checking in from Bangkok with Thomas and Kelsey. The main focus of kind of this past 2-week period was thinking a lot more about actually taking Plasma MVP from working at the child chain level and thinking about kind of the full user experience in terms of just dealing with if we do confirmations, what implications that has, with say a user having to basically sign 2 transactions at a minimum. Those would be 15 seconds apart, which is not great. Also, for Plasma chains in general, we're going to have to deal with signing basically different format transactions than those of Ethereum. So thinking about kind of the best way to implement those signatures, and because people are already quite used to using MetaMask style Chrome extension, we've kind of been thinking about how kind of we could maybe leverage that or something like it to actually interact with the child chains. Yeah.
Cool.
Yeah.
Okay. Do the other teams have other updates? I think the main thing right now is everyone's doing a lot of infrastructure, coding and stuff like that. But and I think it's cool to go over that with the group as well. If you're just we're figuring out the contract or something.
Okay, just for a part regarding the signatures for every transaction, in our contracts, you can just take this part. We use a standard Ethereum personal message and verify it on chain. Works well, doesn't require any additional tools. You just use a web page with MetaMask and you sign a transaction. It's the most trivial solution, but for now it works.
Okay.
We also use the same kind of signatures for Plasma blocks, so not just a signature of the hash itself, but we prepend the Ethereum personal message header, as always. And in general, for update from the Bankex, we plan to roll out the first beta on Rinky by next Monday. So just infrastructure and the full source code for parent contract on the Ethereum chain, which has all the challenges. We disabled withdraw transactions, which we wanted to make faster than as a 1-week delay. We decided to get rid of it for now. And we don't have 2 signatures. We just have 1. Our workflow is user sends the transaction. He inputs few inputs referencing all transactions, make an output, signs all of it. So we don't take any second commitment signature to be sent to the recipient. Only the transaction itself.
Okay. The reason why there's a lot of why there's general belief of 2 signatures is to mitigate certain types of block withholding attacks. have you considered like the possibility that like it might be necessary, or is there an alternative construction? Like, what's your thinking behind that?
If you specify what kind of withholding attack you're thinking about, maybe I can answer it more directly. But in general, the workflow is the following. You submit the transaction which you signed, and it's enough for a Plasma operator to include it in block if it's valid. And you know, when you send, you know almost immediately if it's valid, just because we make it this way. Then as soon as the block is committed to the smart contract, and if you can download the block, the recipient can see that the transaction is actually there, was well formed, and if he has a full client, then most likely he can just decide that, well, transaction proceeded, and it's in chain, there is no rollback for it.
So, oh, sorry, someone.
I was gonna say, so here's how the attack usually works, right? So let's say at time t, account A sends a transaction to account B. So at time t, account A just publishes this transaction. At time t+1, the Plasma chain operator publishes an invalid block, and this invalid block contains basically a bunch of fake exits. At time t+2, like basically everyone starts exiting now, and that's kind of the initial setup for the scenario, right? Now, the problem that you have is that at this point, everyone except for the person who sent that transaction in flight will be able to exit, and their transactions and their exits will have priority because they came from UTXOs that came from before time t+1. Now, the UTXO that was, the UTXO that was spent by the transaction that was in flight at time t and included at time t+2 is, it cannot be exited because the transaction that was included at time t+2 can be used to challenge the exit. The UTXO that was created at time t+2 also cannot be used to exit, because even though you could theoretically exit and it can't be challenged, that UTXO has a lower priority than all of the invalid stuff that the attacker included at time t+1. So basically, like the money that's in flight during an attack ends up having lower priority than the attack itself. And so like basically neither the sender nor the recipient can get the funds, and so you have this situation where money that's in limbo can just get stolen by an attacker that attacks at that particular time.
Yeah, for such particular problem, we didn't find a beautiful solution for it. Our idea was that a Plasma operator who, well, actually has an interest and incentive to work properly in most cases, should deposit something like, let's say, 100 Ethereum to cover only this one block, where for transactions which were in flight, just at t+2. So ideally, it should cover the t+2 block, whole amount of this block with his deposit, so people at t+2 can withdraw from money of the Plasma operator. Something like this. We don't. So let's say a t+1 and it happens, and the Plasma should basically stop. In principle, the t+2 block gets published. It's considered invalid, cannot be used for a challenge. So the sender of the transaction A, so the person A sends the transaction and then exits, because at time t, the chain was valid still. So he exits, and the recipient of this transaction, which is included only at t+2, where the Plasma chain is invalid, can still exit after the whole exit interactive procedure by taking his money out from the pocket of the Plasma operator itself, which is one way of solving it.
Wait, but now, so now person A paid someone and both get to exit the same amount on the root chain?
No, person A exits using his UTXO, which was spent at time t, but still it's considered valid, so he just exits before the global stop of the Plasma. A person who received this money ideally should have monitored and never accepted this money because, well, he should have monitored and seen that at time equal t+1, chain is already invalid, so at t+2, he actually never received the money. Worst case, because we know that some products can be shipped or some services can be made taking this transaction as granted, the person at t+2 who should have received the money still can exit with this transaction at t+2, but now he takes the money not from just somebody else money in a Plasma root chain, well, in a smart contract on root chain, but from the deposit of the operator who uses the deposit to guarantee that the chain should work well, and in case of exits, person affected this way should just take his money.
Okay, so what are the rules for how this this extra deposit can be used? Because like, if there's a rule that anyone can use the deposit,
nothing else.
That what?
Oh, just in case. No, there are no rules for operator or someone to use it.
Okay,
so just the money of the Plasma operator. He deposits it when he deploys the contract,
right. Okay.
and then it's there.
I understand that, but like here's a concern, right? So let's say there's a Plasma chain, and let's say you have 10,000 ETH inside the Plasma chain, and normally there's almost always less than 100 ETH in flight, and so you add a safety factor. Let's say you set the extra deposit to be 200 ETH. So there's 10,200 ETH in the Plasma contract. Now an attack happens, and in the first attack, basically in order to set up for the attack, the attacker will take 400 of their own ETH, or possibly like some amount of their own ETH, and like a large amount, possibly 400, and they'll send it and kind of gather it up into a single big UTXO. Then in the first attack block, the attacker will take that ETH and will just immediately just double spend it. So we'll make a block where every transaction kind of double spends the same UTXO, withdraws all of those. And or possibly, creates UTXOs whose parents don't even exist. And then there will be basically the attacker will, with the way that the order of exits works. So like, let's say the attacker is trying, like there ends up being 50 ETH that's in flight, all the other 99.50 escape. But then the attacker gets their 400, gets their 250 out, and then even still the person in flight's off with nothing. So basically the idea is that in an attack you can you can make the first attack block release a huge amount of ETH, which could be larger than the deposit.
Yeah, that makes sense. I think we should. I was just gonna say, I think we should probably give the Cosmos team a chance to give an update, so we can discuss the details around this mechanism.
Yeah, no major updates. We've been working on the specification a little bit, but besides that, we've not written any more code as of right now.
We have the Solidity stuff for our peg zones done, and we're on the Tendermint chain side of things right now.
Yeah.
Cool. That's a lot of stuff.
Maybe a little bit.
Can I ask a question?
Yeah, for sure.
So for the Cosmos Plasma, maybe I just forgot, but I just want to clarify. If something goes wrong on the Plasma chain, is Ethereum the final settler of the dispute, or is Tendermint core?
So the idea is that you can do root chains. You can use either Ethereum as the root chain or the Cosmos Hub as the root chain. But yes, the root chain is the final settler.
Okay. Switch.
Yeah.
Okay.
And keep in mind, what we're working on we're not dealing with fraud proofs of the state machine whatsoever, right? We're just touching the fraud proofs of the consensus.
Yeah.
Thanks.
Mm-hmm.
Cool. I have one question in general, which I tried to put in the agenda, but now this link to the HackMD.io doesn't work. It shows empty. Are there any plans in general to reduce the price of this new BN 256 curve operations in further forks? Because in general, we already thinking about some confidential transactions on Plasma. And so for exit, we will need the primitives. But they are so expensive right now, even if we use the most compact range proofs and everything. It just, in general, it's not related to Plasma, just a curiosity question.
Yeah, it's a good question. I mean, I know there are some like optimizations to the based to the curve that are being worked in at least one of the Ethereum implementations. Like basically, fundamentally, right? Like there's no principled reason why BN128 should be 20 times slower to execute than SEC256K1. The reason why right now the SECB EC recover so it can have such a much lower gas cost is basically because everyone is using these hyper optimized implementations that have benefited from like 5 years of like work targeted toward Ethereum and the Bitcoin main chain. So it should be totally possible to replicate those gains for BN128 as well. And I have seen some preliminary results and they look very promising. So it does seem like large reductions in the gas costs for like all of those opcodes, and including quite possibly the pairing stuff, so that like you can do BLS signatures, which might be really great for Plasma implementations. Like a few times cheaper.
Yeah, I meant mainly the like the main curve group, not the extended group or pairing operations, just the primitive.
Yeah,
like
I was talking about like EC add, EC mull, and EC pairing, so all of them.
You don't have to necessarily compute them if it's presumed that you create an interactive game off of that. You just push the data, don't actually compute the data on chain, but everyone has the data and anyone can dispute it.
Yep. Another thing that might be worth considering is I know with a lot of this like ring signature fancy math, there's ways to aggregate proofs and like basically just verify one on chain for a huge pile of exits. Like I'm not really well versed enough on the math to know how feasible it is for that particular case, but it's probably worth looking at.
Well, yeah, we try to use just to reduce the size of the transaction and the amount which is sent to the main chain in case of normal operation. Just in case of normal withdraw operation, you just want your money on chain. Still, the size of the proof is small, and we want it as small as possible, so that we send a small transaction. But still, the number of scalar multiplications is somewhere around 140 per 164-bit precision integer.
Mm-hmm.
While we can still aggregate, it's already a lot. So it's necessary for normal operations, not even just exit, when everyone exits and there is interactive procedure, just if you want your money on chain.
Right, okay, well, hold on. So if we're not talking about exits, then all of this happens inside of the Plasma chain, in which case like main chain gas isn't the issue. The issue is just raw efficiency.
Oh, no, yeah, what I meant is, let's say, well, Plasma is not there yet and not everyone uses it. Let's say you can use it for some purposes. And let's say for some purpose, you collected a lot of money Plasma.
Right, I see it. You're just talking about like general use of...
and want to use it. Yeah, so this kind of operation is still impossible just due to high prices. But yeah, they will be necessary for exit anyway. It's just a long-term plan. We see that we have more or less the primitives, but price is a killing.
Mm-hmm. Yeah.
Mm-hmm. Yeah, and I think you could defer a lot of that by having a bond, and the bond essentially covers the cost of computation, but then you're not actually expending that on chain. Okay, I think we need to move on because I think the Axiom Zen guys are here, so I think lastly there's I assume the consensus people and then the Taiwan team.
And Elaine.
Oh, Elaine, hi.
Hey, yes,
How have you been?
great. I'm in the Bay Area now. We set up office in Sunnyvale.
Oh crap! I didn't know that. Okay, let's hang out sometime this week.
Yes, that'd be great. You
Cool,
should also
cool.
come and visit our office.
Okay.
Do you want to give a quick update regarding whatever plasma, especially, but
You're asking me?
yeah, why not?
Oh, sure. Yes. So I guess we are working on implementing, like getting this fast path fully working right now, and like also integrating it with EVM. I'm just kind of I wanted to be kept up to date on the plasma front. So if we could at some point start maybe integrating with the plasma approach, then we would potentially keep that in mind.
Cool.
Cool.
Okay.
Any other updates?
Hey.
Gianti.
Hi. So currently we are we have already implemented the client part, the node part, syncing multiple nodes on Plasma. We have already pushed it. Now we are thinking over making some kind of the test framework for Plasma. So let's say new implementers are implementing Plasma and custom Plasma. Let's say DEX, decentralized exchange. So the problem is that we don't have any kind of the list of scenarios or stories how chain can be can commit a fraud and so on. So we are thinking on creating those scenarios, and whenever a new implementation comes to the market or to the public, they can always validate their implementation with the list, or you can call it Plasma test, and you can score your the implementation as a Plasma score. So something like that. And other thing I want to say is that the Benket question is like I think he's trying to say actually the Plasma's philosophy is that you are not trusting the chain operator or any other authority here. You are actually using the Plasma chain as a many-to-many state channel. But if you are so when you implementing a Plasma node or Plasma chain, you have to make sure, okay, any point of time authority can commit a fraud, and everyone in the chain should have their ethers.
Yeah, and Gianti, maybe do an introduction for people as well.
So my name is Jayanti Kanani. I am from Mumbai, India. So I was a solo researcher on Plasma and Ethereum. I mean, then I made the Esteban Decentraland, and we sort of collaborate on on Plasma. So we are working together on Plasma thing. Plus, I also work on a sidechain trustless breach.
Cool. And maybe post your repo as well.
Yeah, sure.
Everybody else.
One more thing. I'm actually trying to create account-based Plasma, as I say to David before. So I'm trying to come up with like a hybrid UTXO and account-based solution. I'm working on it. It's VIP, but I'll post you if it's ready, whenever it's ready.
Cool. Awesome.
Yeah, the Balance One Plasma is a great idea. We're also working on it in terms of trying to make a snark which can work on a tree of the balances. But for now, we just working on an example of two balances, one transferred to another with the transaction, and the root of the tree being the public input to the snark, and all other elements being the private inputs. But so far, I don't think we made any progress.
Okay. And then Gunnar Huang.
Hi, this is Taiwan team. And last 2 weeks we do some change about simulating the account base by merging the UTSO. This is actually advised by Vitaly before. And so basically, when a user get another UTSO, get another fund, and we will check if there is two UTXO belong to the same address, and so we can merge it to the one. Yes, and this is kind of merging the UTSO to simulate the account base by UTSO model. And a few days ago, we discussed with David about some kind of cooperation. So maybe in the near future, we will try to working on together. Maybe, yeah, we are all looking forward.
We are starting for Omisego Plasma MVP. And can I ask a question?
Mm-hmm.
Can anyone see the schedule in the email?
No, I can't actually.
Yeah, I open it. I try the Safari and Chrome.
Yeah. Well, yeah. So happens we have the data in the cloud. Oops. Single provider, right? Proof of authority on data. Good.
Let's exit.
Okay, I think maybe we should change gears now and maybe have the Axiom teams introduce themselves and then talk about their problem and maybe background and sort of like interest in being in this call and stuff.
Oh, so hi, I'm Fabiano. I wrote the Solidity contracts for Cryptokitties, and this is...
I'm leading on the product team. So we're broadly looking at scaling solutions right now. And of course, Plasma came onto the radar. Roham, one of our colleagues, I think engaged with Vitalik at one point, but we wanted feedback from you guys about how you think Plasma could maybe work, because we, between Vitalik and Roham, they couldn't see a solution, but we thought, Joseph, maybe you would have some other ideas.
I think, okay, so quick background. This call is being recorded, so it is published. I'm just double checking that you guys know this. So maybe for, as I think most of us in this call are familiar with the problem set, but maybe give some quick background overview about like scaling commands for Axiom and Cryptokitties and stuff like that.
Sure. One of the main operations, so what happens the most in Cryptokitties is people breeding cats. That's the I guess, arguably the most fun part of the game. So people get two cats, and all the cats' data live on the contract. All of the, by data I mean like the genes, not the images, but the genes live in the contract. And there's a bunch of attributes, like if they're pregnant, when they got pregnant, from whom they got pregnant, and everything. So it happened in two steps. Basically, one step is getting, you get two cats, one of them is gonna get pregnant. The one that gets pregnant, the data changes a bit. And at a second time, like when it's ready to give birth, any user on the network can call give birth, and they get the deposit that was made on the first step. So they also get paid a little bit. And a new cat is born. So whoever owns the mother at this point owns the new cat as well. So we keep 2 words per cat plus the ownership, which is another word to map. So we wonder if there's any way that it could work on Plasma chain or do this kind of thing to do faster. We're very, very likely that our current contract cannot scale into Plasma in any way, but maybe there's some solution. And just to think in like a more general sense, if not Cryptokitties, then how would ERC-721 kind of tokens work in Plasma?
Yeah, those are interesting questions. I think, so I have like a proposed solution, but it's kind of janky, so I kind of want to hear what other people like think first. If no one else has opinions, I'll go in a long rant.
Well, most likely we will just implement a separate asset field and link it to the contract. So far, it's the easiest and the cheapest solution. Just extend the transaction to include the asset ID.
Okay, so
yeah, like I mean, I don't see like it's just a matter of like modeling this into a UTXO system where like, you know, each cat is its own token basically.
So number one, I think like this is all true. Like what you guys said is definitely true for trading cats. But I think their problem is interesting insofar as that they have a problem of they want to be able to breed cats inside a plasma chain as a possibility, because the requirement for that is, I think that's the most expensive, correct me if I'm wrong, that's the most expensive part of their contract. And if that's the case, you now have the synchronicity issue between global state and local state. And also the issue of block withholding within the plasma chain, of how do you mitigate that, right? So I think those are the two most fundamental issues. Now that said, like what they were saying just now is just you can sort of trade efficiently Cryptokitties, but maybe like not breed under that construction. And that already gets you pretty far, but is it like maybe it'd be better if we could like do all of it and let you breed inside plasma chains. And the problem with that is, well, if you have block withholding, you don't really know the source of that. You don't know whether they correctly did it or not. So here's what I propose. And this may sound insane. Like I really want your feedback on this, Vitalik, because I don't know like whether it's in line with like how you see things, because this is gonna get like kind of wacky. So if you presume that you have like a plasma or plasma-like construction for trading, what do you do about breeding? What you could hypothetically do, and bear with me here, and I'm going to run over this really quick. So like, if you have questions about this, definitely like bring it up, because I'm probably not going to do the best job explaining this, because I just came up with this probably like a week ago as a possibility. What you can do is, and apologies for not reaching out to you earlier, the Axioms of team, like I just didn't have a good solution for you guys. And this is not a great solution, but it gets you there, I think, which is you do it counterparty style. We're going back in time to 2014. So what you do is you make it so that anyone can do breeding, and then maybe you do like attestations of, you know, a large group of cats being bred on chain. So you have a 32-byte hash with some type of like money being burned or given to miners or something like that to enforce like, you know, service attacks. But essentially what you do is you guarantee the provenance of a cat's birth and all subsequent transfers, because you verify the available chain history, whether it be on the main chain or in all possible plasma chains. If you cannot get a step in the chain, in the history of transactions, i.e. the provenance is unknown, that's equivalent to the provenance of an art piece being unknown. And therefore the valuation should be much, much lower or close to zero. Effectively what you need is, you need client-side verification of the provenance of the cats. And essentially, any third party can provide this provenance and verify it for you, but essentially, you need to be running a full node across the history of it. And you don't have to have all the chain history of all the different like plasma chains. You just need the subsequent data and proof in order to do that. The presumption is people like Infura, I don't know, like all the people doing like basically block explorer type stuff are going to be able to parse that. And the benefit of this is that you can do breeding inside the plasma chain and then transfers and trades off of that. So it's different than counterparty insofar as that you can trade fungible assets with those. Here's the trade-off of this construction. I do know Cryptokitties has limited edition kitties, and there's no guarantee of the set size if you wanted to do it in a decentralized way. So if you had limited edition kitties, you would need a central issuer, which is fine. You know, like it's basically someone saying, okay, clearly you guys bred it correctly. Here's this kitty, and now there's sufficient proof. Do you follow along, or am I like completely like not explaining this correctly?
Yeah, I mean, so I guess if it's client-side verified, then that does have like a couple of changes. Where one is that it's not clear how you would exit a kitty, because like if it's fully client-side verified, then there's not going to be, you're not going to be able to just use one UTXO to exit.
Oh, you can do exits in the same construction theoretically. So essentially, after it's bred, let's say, you issue an exit transaction, and then the exit proof takes precedence. Right. So then the presumption is everybody has that data, and then you can then verify the provenance sufficiently.
So one problem is that if you assume that they're going to they're going to exit eventually, which is basic, then if the breeding is the kind of the dominant behavior, then in the long run, it actually doesn't save you any gas, because like basically you have to instantiate all the kitties on the main chain eventually anyway, and we're just kind of haggling over whether you do it earlier or later.
Oh, what you save on is the computation. So what you do is essentially you're just committing to the creation of, an ERC 721 that any user can create. So essentially you're just doing the push data plus the associated creation contract, and not any of the computation. I don't know if that saves enough, but basically, and maybe you could have direct transfers between plasma chains as well. I don't know what that looks like, to be clear, but you should do that.
So if that's the goal, then you could do just like a simpler approach where when you breed, you just kind of like, you just commit to the results of the breeding on chain, and then like it just happens if nobody challenges within 24 hours. So
yeah. I think, basically you need, as part of this, like basically for breeding, you need a commitment on chain. And then, which is, pretty small, 32 bytes plus signature or whatever. And that could encompass, potentially hundreds or thousands of breeding activities or more. And then you leave it up to the client to make sure that that was done correctly. And if there's no history of this commitment, then you presume that they're playing games with the randomness generator. But if there is a commitment, and you probably need a two-phase commitment, effectively you can do breeding, but it's up to each individual client to make sure it's worth anything, because the presumption is you just leave it to market forces if there is insufficient provenance of both the breeding and any intermediate transfer. You guys think that works?
Another longer term idea I had is that like you can do a bit of a semi-trusted solution where you have some ZK snark scheme where you basically say, this was the old Merkle root, and here is the new Merkle root of like all the child kitties. And then like basically the idea is that when you breed, you would like do it through some particular breeder. And like, yes, the breeder can deny you, like your breeded kitty if they end up not publishing the data, but like generally they're not going to do that. And like, because Cryptokitties is a game, it doesn't really matter if breeding fails a few percent of the time, because it's not like people are like really like losing outside resources. And then like the snarks by themselves are enough to make sure that the breeders aren't kind of breeding kitties that are not supposed to be bred.
Yeah, that makes sense. And then you have a commitment there. Then you're good to go. Like, be breeding X number of cats, you run the ZK snarks proof, and then you provide proof of results. And at that point, you're good to go. Yeah, these both seem like decent options. Like, I don't know which is more like challenging to implement, but I think like both are pretty doable in terms of breeding inside plasma chains. I think the general limitation is a limitation on limited number of cats. Because there's no guarantee that you know exactly what's going on in each individual child chain, and you need to be able to do computation on possibly, hidden data. So at that point, you just need a central distributor. And I think like limited edition cats are like a pretty specific case that can be worked around. But in general, that way, like breeding can work under this construction. I like what I like about the counterparty style construction, where it's client-side verified, is that it should not be too much work, hypothetically. That basically, like, you know, like basically what any plasma chain implementation, it's like very, very small in terms of additional work on the infrastructure side. And then at that point, you just need client-side verification and stepping through the various plasma chains. And that could be done just by like saying, okay, we're gonna like only verify these chains. And then at that point, you add in a one by one kind of thing. And then eventually later on in your roadmap, write in something that can, like, you know, traverse through partial history.
That's super interesting. Yeah, thanks for sharing your thoughts. It was good to have you two challenge each other's idea. Questions that we didn't even come up with. That was really good.
Yeah, definitely, like,
to be clear, both of them do work. Like, I think like both constructions work. And what Vitalik was saying definitely works better long term. I think that's definitely probably the more interesting construction. I hadn't considered that as well. But I think in the short term, maybe some type of like, you know, iterating through things. Unless you guys have like a ZK Snarks.
Yeah, that stuff is a lot more than what we like to implement at this point.
Yeah. But I think you know that probably is optimal. But I think, you know, right now, I think like if you have someone that knows how to like traverse through transactions, I think that could be a way that you can scale up Cryptokitties pretty far, I think.
Yeah, one problem that we realized way later is, and what makes things a lot harder for us, is that the kitty IDs are sequential. So it's like, yeah, it's 1, 2, 3, so on.
Oh yeah, just do a hash of the just do a hash of the kitty plus the nonce, and then committing to, as part of the ID, maybe the block height which it's committed to in terms of the birth, and then that should get you there. Block height plus like you know, transaction order or something like that.
Yeah, that's true. Yeah, it'll be interesting to conciliate later, but after they're born. But yeah, it's challenges we would have to.
So I think one thing to consider, I think, as part of like both what Vitalik said and I said, is that essentially both of these constructions have a presumption that there's not one single issuing contract of kitties. And if you did that type of thing, you might need something in addition to maybe EIP 721. I think. I could be wrong here. But it's something to consider as well. I don't know. What do other people think?
I don't think the ERC20, ERC 721 stuff really matters, because ultimately at the end of the day, it's just a token that has one unit, and you can basically treat it as a token with multiple units and it'll work.
Oh, okay. Yeah, that's true. Yeah, I think this is like pretty doable on the Plasma side, like quickly after there's an implementation working, you know what I mean? There's not too much of an impediment. It's just adding data types on the Plasma side. And then like allow you to accept Cryptokitties as part of the Plasma contract. And it would be accepting of arbitrary Cryptokitties. So you can be depositing like Cryptokitties that were like incorrectly bred, and that's fine. And it's up to like the client to like ensure that that's valid or sufficient ZK snark proof of the creation of the kitty and transfers. Yeah. Are you guys familiar when I mean like counterparty-like constructions?
Like the whole idea that you basically users kind of execute all transactions in the state sequentially themselves.
Yeah, only for the kitties though, because when you deposit ETH into the Plasma contract and you trade, the trade is like enforced and valid and everything like that. And basically like the CryptoKitty that you're receiving is going to be like the CryptoKitty that's deposited inside the Plasma contract, but it's sort of like is this CryptoKitty have correct provenance? I don't know. Nobody knows. It's up to you to figure out. And then like, the Plasma contract's going to accept it either way, and then you can trade your ETH for it. Like, it's up to you, If you bought a garbage kitty with no good provenance, that's up to you, that kind of thing. One thing I find interesting about this is that basically you're dealing with notions of, globally shared views on local generated data which is generated locally, because I think a lot of the presumptions that we've been operating on is that, there's an ERC20 generated on chain. And then it's that sort of like efficiently scaled up. The problem that CryptoKitties is facing is that they want the data to be locally generated and then globally accepted later on. And this is an interesting problem because this basically, if this problem set gets resolved, this is essentially any type of data structure problem, which is localized. I think like this might be an alternative or even maybe possibly better construction of doing things like, things like arbitrary data storage and transfer of like information and stuff like that. I think like I think it's interesting to have them on the call simply because like maybe it'll be helpful in terms of understanding the problem set and sort of like maybe keep in touch with them if there's like, understanding of their needs, and it's sort of like, maybe it's sort of like an emerging use case of like how to think about, the blockchain and like how you do data storage and how you do localized computation with the states.
Yeah.
I don't know. What do you all think?
Yeah.
Take up the call.
I was thinking about like a similar thing yesterday about like, what if I have like DAI generation on like different blockchains, right? Like, does that, and I was thinking about it, like, I guess this means that like DAI generated on different blockchains are never going to be fungible with each other.
What do you mean by DAI generated? Sorry.
Like the MakerDAO DAI.
Oh, DAI.
Yeah, sorry. Yeah, so like if I have like the same DAI generation like contracts on Ethereum and Ethermint, but like I don't know if those DAI that are generated can ever really be fungible with each other.
No, they're two. Like, if there's two contracts on two base blockchains, that they can't be fungible. I think what you're looking for is like you want to just use the DAI that already exists and that's based on the Ethereum chain, and then find ways to kind of like bridge it. So like basically on the Ethereum chain, it gets controlled by a bridge contract, and that bridge contract then allows it to be moved around on the Ethereum chain.
Right. Yeah, and I was just like trying to like think of like, it seems somewhat related, like but like it seems a bit easier with CryptoKitties. Like, can't you just like, I guess this is kind of what you're saying with the counterparty thing, where it's like, you just accept that certain kitties are like less trusted because they were created on the Plasma chain rather than on the root chain.
Yeah.
Well, it's sufficiently trusted if you have the data. It's that if you don't know how the breeding process went, and you don't have the data for the breeding process, then you're just like, well, these kitties are worthless.
Yeah.
But if there's sufficient provenance, you're just like, oh, okay, I guess it is legit. It's sort of like the provenance of like art and stuff like that. I'm going full circle.
Whoa.
And then I guess, Carl, do you remember like what else was on the agenda?
Dang, that's a hard question. Not too much. Let me see. What are some good topics? We went over the UX, CryptoKitties. That was number one.
No, it's okay. We only have 2 minutes left.
Okay. I think we covered quite a bit. I think
we covered quite a bit.
One thing that would be super helpful maybe is just because you and Vitalik have more experience kind of and especially like more intuition in terms of kind of like the next steps for kind of taking Plasma further. Just kind of maybe sharing areas of research that you're excited about, or that you think could use kind of like further looking into with everyone here?
So personally, I think like a lot of what we're talking about the call today with Cryptokitties could be pretty interesting. I think sort of like dealing with notions of provenance, a contract which is willing to accept arbitrary, arbitrary state attestation, and then it's up to the individuals to figure out is pretty interesting. The details of that definitely haven't been worked out. If there's some type of ZK snarks construction, how do you resolve that generation and then transfers? I think it's unclear as well. And then, I mean, this is all doable. It's just like the actual like implementation. There's probably a couple like tweaks that need to be figured out that are not trivial. They're just like, oh wow, okay, you need this thing, and that could be pretty interesting to work through. I think making sure that like it's not like implementation like working with like the CryptoKitties type problem set, but it's mostly like like in consideration of that way, like while it's being implemented. And what I think is fairly interesting is that this could be used for things like essentially an efficient way to do without fraud proofs, like various CRUD data storage type problem sets, where it's like you wanted to put Reddit in a plasma chain. This could be an alternative way to do it.
One of the things I continue to be interested in is seeing if Plasma can be expanded to a general purpose EVM style blockchains.
And definitely removing the second confirmation in transactions. That is a big one. And by the way, David, I don't mean to give you like work. But writing something up on the like UX issues and kind of like what that is and like what the current thoughts are, I think would be super helpful for getting other people involved to solve that UX issue, because we definitely need to make this like super user friendly.
Also, improving the strength of the guarantees that Plasma can provide with latency faster than like block finality time. So basically, like for it to be possible that like I send a transaction, and then I send it to the Plasma chain operator, the Plasma chain operator sends something back, and within 500 milliseconds, I have reason to be like, ideally, kind of have like with state channels have instant finality. But if that's not possible, then I guess close to that is possible.
Yeah. Oh, I see what you mean. You like maybe like have some bondage limitation of like state transition.
Like the simplest thing that you can do, right, is that you send the transaction, and then the Plasma chain operator basically replies back with a commitment that says, unless there exists a Merkle branch of this particular block of this particular block in. Or of this particular transaction in the next block, then I agree to lose my entire 10,000 ETH bond. But then, which is pretty good, though, with the caveat that technically doesn't apply. Just if the next block just happens to be the first block when they start an attack. But even still, that's a pretty good assurance. The question is, can we go even higher?
Yeah, I think like basically, I think. At least if the total value of value being transferred during that time period and a greater amount is going to get penalized to the miners, then it's safe. Of course, you can have it go back to the individual participants as well, but like at least to get that guarantees that like they're not colluding with individuals to get that bond on chain. And it's like going to miners no matter what.
Because like the concern with all of this is, right, like if let's say A sends a UTXO to B1 and the same UTXO to B2 and the same UTXO blah blah all the way to B200, then that particular sender is colluding with the Plasma operator. The Plasma operator basically just signs all of those, and then it looks as though there's like 50 people that got defrauded that might deserve to be compensated, but you obviously don't want to do that.
Yeah. Yeah, I think making things fast is definitely a good, interesting research problem. I'll be honest, it's not my area of expertise when it comes to like this type of issue.
And of course, layering.
Yeah, you have to do that. Yeah.
So I was just going to say, of course, adding proof of stake validators, and it's another fun one.
Yeah. Yeah, I think Elaine is definitely the expert on that one right now, and the Cosmos key.
Ooh, here's another fun one. Using proof of work for the plasma chain. Now, obviously, you need to basically say, so like, here's what we do, right? Obviously, you need finality for proof of work. So what we do is we just like ban reverts beyond a certain length. The reason why we do this is so that we can do kind of reverse takeovers where we basically say that, I don't know, like Bitcoin carbon dioxide or like one of these crazy works. Yes, basically we just, on the Ethereum side, we just say, oh, we are turning you into a plasma chain. And now you have the right to just go on and trade your stuff into an ERC20. So you're really just an ERC and ERC20 with this other proof of work way of trading it. So go ahead and come and be the join the ERC20.
So personally, like, I know this sounds like wacky, but like, I'm actually very enthusiastic about this topic. I think like there's a lot of like potentiality with this. One of them is like, if you did put in proof of work mining as in there, you can like add on merge mining, right? Like you have a contract that does merge mining, and then like you leave the rest up the stack. I think that could be pretty fun. You just, you know, do it inside ETH and then you're good to go. I'm very enthusiastic about this topic. If someone wants to implement this, like, I think that'd be so much fun. What I mean is I personally want to use this. For like a project. Yeah, that's a fun one. Wait, so what do you do about like, oh yeah. Just if there's reorgs, you have to be able to process. No, well, yeah, you probably have to process reorgs. So. I don't know. I haven't given this enough thought. That's fun.
Next time.
Yeah. Okay, cool. Do you have any other closing thoughts, questions, the Axiom Zen team? Because like you're the guest for this call, I guess.
Well, yeah, like you gave us a lot of really good insights that we'll definitely take back to the team. So thank you so much for having us. I think you mentioned it's a bi-weekly call. We would love to come back next time and give you thoughts on the extra chance to do after sort of reviewing the two.
Okay, I mean, this call is generally for people doing an implementation. Definitely, if you guys have any thoughts in between these two calls, we can definitely have another call or like one more call when it comes to updates and stuff like that, and maybe further questions that you and your team have.
Yeah, that'd be awesome.
Okay, cool. Yeah. See you in 2 weeks then.
In 2 weeks.
Yeah, thank you everyone for sharing your thoughts. It was really helpful.
Okay, thank you.
Bye-bye, guys.
Bye.
All right, everyone.
Bye.
You. Bye.